Hello everyone, this is a video lecture for College Algebra Math 1414 Section 3.3 Long Division. Yes, very long. Um, it's not that bad. There's also some other stuff we're going to have here in a minute, but long division is the first thing, so let's talk about it. I'm going to do a long division with just some random numbers, if that's okay. Let's do 23 divides 5,701. I'm sorry, 571. I was going to make it bigger, but that's fine. I want to know how many times 23 goes into that. So, I say, 23, does it go into 5? No. Does 23 go into 57? Yes. How many times? Is it 2 times? 2 times. And then I'm going to multiply this here 2 times. The 23 is equal to 46. Subtract those. And I get, what, 11? Cool. And then after that, I bring down the next term. Does 23 go into 111? Yes. How many times? I don't know. 4 times. You had to use a calculator there. 4 times. So then I multiply 4 times 23 is 92. I subtract these. Calculator. 19. We got 19. And that is my remainder. Sorry about that. Seem to be doing that a lot today. Okay. And that's my remainder. Cool. This is called your quotient. And let's put it all together. What does this really look like whenever I, do mathy math? Well, I'm saying 571 divided by 23 is equal to 24, and then plus 19 over 23. That's the answer. What I'm trying to say is that I had 24 of them go into this, and so you can even verify if you like. I'm going to say 23 times 24 is 552, which is a little bit less than that, so that's good. And then I'm going to have some left over, okay? Again, quotient, remainder. We're going to see this in my math lab as well. Quotient, remainder, that kind of idea. Notice that the 23 is the same here and there because it remained behind. It remained behind in the fraction, I guess. Okay. Like I pulled 24 out of here, but this was left over. That's kind of the idea theoretically. Let's do some actual math here. 333, here we go. I got x cubed minus 5x squared plus 9x minus 5 divided by x minus 1 is equal to, and they got box plus box over x minus 1. Well, I didn't know it was going to be this complicated. I thought it was just numbers. Yeah, I'm going to rewrite this in long division format. And I'm going to do long division with this. Now, in the future, if you're watching this just to watch it, taking notes, and then you're going to go do your homework here in a little bit, you can actually do this without long division. And I'll show you that strategy later. But for now, I'm doing long division because it's an easier problem. We need to learn it, so this is good. Because it'll get harder and you have to use it. So, this is the process. Sometimes I write a big list of what I do. I figure it's a recording. You can pause and rewind and all that kind of stuff. So it's a long process, but I'm going to go through it. I'm going to talk you through it. First off, divide the leading terms. Divide the leading terms. X cubed divided by x actually ends up with an x squared. And so I'm going to put x squared right here. Now it's a 1x squared. You don't have to write a 1, but I want to keep all these x squares together. Okay, I want to keep all those x squares together. All right, I then multiply this by each term, just like we did with the numbers. I'm going to put it down a row. So x squared times x is x cubed. And x squared times the negative 1 is negative x squared. Notice that these are always the same. If you don't have these the same, something is wrong. Something is very bad. I then want to subtract. And you notice what I did here. Back on the last one, see, I multiplied and then I did this subtraction sign, right? It wasn't originally a negative 46. It was just 46. And I said, we'll subtract them. That's what I'm going to do here. So I have this and I want to subtract them. Now, that's proper math right there. You're looking at some proper math. Look at that. Yeah, I'm not a proper kind of guy. What I'm going to do, instead of saying subtract, I'm going to switch the signs. Now, it is much easier for me to switch the signs because I have a whole lot of colors. And so I could show you all the different colors about, you know, it was this, but now it's that, and da-da-da-da-da. Using just a pencil or pen, it might be a little difficult, but I still recommend it. I've been doing this for a long time, and I think that this is an easy way to do it. Switch the signs. Notice that was a positive, now it's a negative. This was a negative, now it's a positive. And it makes it much easier to go through each one and add them up. So add, subtract, whatever you got to do. These guys right here make a 0. Always, always, always. You should always get a 0 there. This here, we got a negative 5x squared plus 1x squared should make a negative 4x squared. Last step. I'm going to use yellow, I guess. I'm going to bring... Oh, not yellow. Oh, I can barely see that. I'm going to use magenta then, I guess. So bring down the next term. And then you repeat. So take the leading terms off to the side. I got negative 4x squared divided by x. And I get a negative 4x. I'm going to put it right there. Okay. I'm then going to multiply and distribute, bring it down. Negative 4x times x is negative 4x squared. Negative 4x times the negative 1, two negatives make a positive 4x. Switch the signs. That's now, it was a negative, now it's a positive. And that was a positive, now it's a negative. Big negative. That just looks sloppy, doesn't it? Eerie, eerie, eerie. Now he's a negative. So we got a 0. Always, always, always get a 0. And then here we got a 5x. Last thing, I'm going to bring down the last term. Sorry, it's kind of going sideways here. Okay, last one. I'm going to multiply the leading terms off to the side, and I get a 5. A 5, a positive 5. Multiply, distribute, bring it down. 5 times x is 5x. And 5 times the negative 1 is a negative 5. Ooh. Notice I'm going to change my signs. 0, always, always, always. But now this yields a 0, and that actually is my remainder. It is okay to get a remainder of 0. That's a good sign, actually. Okay, and that's your quotient up there. Quotient. Yeah. Okay, so how do I put it in my math lab? They got a box, and then they got another box, and then they got x minus 1. Well, this is a 0, remainder 0. Quotient of x squared minus the 4x, and then plus 5. Okay. My, that took a long time. Probably because it's long division. We're going to do another one here, okay? This is the last one I'm going to do, but this is actually required to do it with long division. Sometimes it'll say, hey, use long division. If it says use long division, use long division. I'm very serious, especially on tests and stuff. They're trying to actually help you a little bit. This is good. We like this. So box, and notice that again, I'm leaving my denominator here. It's the same denominator because it remained behind. Quotient, remainder. All right, long division. Here we go. 2x squared plus the 2x plus the 9 and big division. Whew, man. Do you ever like pause the video for a little bit, come back later? These won't be the same color codes as last time, but still I'll try to make it colorful for you. Divide the leading terms, and I get the 2's cancel, and I get just a plain old x. And notice I'm trying to line them up again. I'm going to multiply and distribute to each one of these and bring it down. X times 2x is 2x cubed. I'm sorry, 2x squared is 2x cubed. X times the 2x is 2x squared. And then x times the 9 is 9x. I'm then going to switch my signs. That was positive, now it's negative. Oop, hold on. This was a positive, now it's negative. This was a positive, and now it's negative. Switch the signs. So I got a 0. Always, always, always a 0. But here, notice negative negative makes a negative 4x squared. And these guys right here will make a negative 3x, bring down the last term. So this is actually going pretty fast. Divide the leading terms off to the side. Negative 4x squared divided by a 2x squared. The squares all cancel. The x's all cancel. Well, x squares cancel. And then, of course, I got a negative 2 left over. Now, let's just say they were wanting just your quotient. Well, you're done. That's your quotient. You're done. They're going to want a remainder here. I mean, it might be 0. It might not. I don't know. But we have got to keep going. Negative 2, multiply, bring it down. Negative 2 times the 2x squared is negative 4x squared. Negative 2 times positive 2x is a negative 4x. And negative 2 times the 9 is a negative 18. Switch all your signs. Positive, positive, positive. Woo! Zero it out. Here we got a 1x, and here we got a 20. And that's my remainder. So remainder, quotient. And so I'm going to build the boxes again. We're going to see what it goes in here. So it's 2x squared plus the 2x plus the 9. Okay. All right, so in this box here, I'm going to put x minus 2. That's my quotient. My remainder, it was the x plus 20. You don't have to write a 1. This is totally fine. Whew, man. Those are so long. If it says do long division, do long division. But we have something new. It's called synthetic division. Now this is happy days. Let's talk about synthetic division. I'm gonna do it. I'm just gonna do it with the next problem here, because why not? I got 2x cubed plus 5x squared minus 6x plus 8, and all of this divided by x minus 4. Wow. If I were to do long division, it would take forever. But let me do the synthetic division. I'm going to tell you how this works. First off, I want to rewrite this. You do not have to do what I'm doing here to do synthetic division. I'm just wanting to show you. I'm wanting to show you that it's a fraction. That's actually what we're doing. And yes, we're going to try to get quotient remainder kind of stuff in the end. Totally get it. But it looks like this right now. What I want first is, what is the 0 from the bottom? That's what I say, the 0 from the bottom. And I'm going to solve for x. Solve for x. What do you get? X equals 4, right? 4. 4 is the number that I'm going to be using. I call it my pivot, but I mean, it could be anything. I'm just saying that's my 0 from the bottom. That's the number that's very important to me, and it's going to be helping me along the way. Now, time out. If I had a problem where I could not find this 0 in the bottom, you can't do synthetic division. So, like, for example, I'm going to ask, look back right here, find the 0 from the bottom. Well, first off, there's actually 2 zeros in the bottom, and you can't do that. So this is no good with synthetic division. But if we went back to the first one, and I said, hey, find the 0 in the bottom, because we're going to rewrite it as a fraction. It's right there. Solve for x. What would you get? 1. You could use synthetic with this guy, because you found a 0 in the bottom. Okay. That was what I was trying to make. So 4 is my important number. I like to call it pivot, but it's probably not called a pivot. I just decided to call it a pivot because I can. It's pivotal. 4. 4 is the most important number to you. We're going to use that on the far side. And then I'm going to write all of the leading coefficient. No, not leading. All of the coefficients out right here. 2, 5, -6, and 8. I'm going to bring down the first number, and we're ready to go. And then I'll start doing the math here in a second. Notice that I'm just taking these numbers right here and writing them here. If you have every term, cube, square, x, constant, so then this is no problem, everything's good. Well, I like to remind myself that that was an x cubed, and this is an x squared, and this is an x, and that's a constant. I like to remind myself about this. Otherwise, I might forget whenever I start doing a lot of math or something, okay? So I do that on purpose. It is not required. Only the red is required. But I'm doing this because I want to see it. So let's start doing this synthetic division. 4 times the 2 is 8. 5 plus 8 is 13. 4 times the 13, calculator, 52, probably should just look at my notes there, -6 plus the 52, 46, 4 times the 46, 184, and then 184 plus the 8, see right here, 184 plus the 8 makes 192. And that's your remainder. You did, finger quote, long division here in just a couple seconds. And in the future, it's going to go much, much, much faster because you're just going to remember that what are the steps? You multiply, and then you add. And then you multiply, and then you add. And then you multiply, and then you add. And you multiply, and you add. And that's it. Multiply, add. Multiply, add. Very fast. This is very fast. Now, I still need my quotient. My quotient actually is right here. Now, notice I had an x cubed. Now this is an x squared. I'm reducing it by 1. I'm always reducing it by 1. And so then I got 2x squared plus 13x. Plus the 46, that's my quotient. And then plus, and then my remainder is 192, all over the original x minus 4. That's your answer in my math lab. Look how fast. Look how fast. I love that. Let's do a bazillion more of these. 3, 3, 23. I got 3x to the 5th minus 3x cubed. Watch out. Plus 3x squared minus 7x plus 5, all divided by x minus 2. What's your 0 from the bottom? X equals 2. So 2 is my pivot. 2 is my 0 from the bottom. I'm going to start writing the coefficients out. I got a 3x to the 5th. I got a -3x cubed. Whoa. I did that on purpose. So the point is that we're missing a term. Where's my x to the 4th? Well, it's 0x to the 4th. Those are supposed to be question marks. 0x to the 4th. And that is why I write these on the top. Not required for the math, but it's helpful to know if I have to have a placeholder. A placeholder. Keep going. -3x cubed. +3x squared. -7 regular x. And then finally my constant of 5. Bring down the first term, and here we go. 2 times 3 is 6. 0 plus 6 is 6. 2 times the 6 is 12. 12 minus the 3 is a 9. 2 times the 9 is 18. And 18 plus 3 is 21. 2 times 21 is 42. 42 minus the 7, I should probably know that one, is 35. And 2 times 35 is 70, and 70 plus 5 is 75. And that's, again, my remainder. Look how fast that was. Did you notice I stopped using all these arrows all the time? I was doing that because I wanted to show that original flow, but eventually you don't need those arrows all over the place. Just do the math. Multiply, add, multiply, add, multiply, add. And let's write out my final answer. This was x to the fifth. Now it's x to the fourth. And so 3x to the fourth plus 6x cubed plus 9x squared plus 21x plus 35. And this is where it gets interesting. Plus the 75 over the x minus 2. You need all of this in one big box. One big box. Why? Why is that? Because my math lab on this very particular problem does not have a remainder box. It just has the single box. I still had a remainder, so I had to type my remainder out by hand. I had to do this. I had to write it out by hand because they did not already include it. Normally they just do that and they, figure it out with the new box. But they didn't have it, so therefore I had to do it on my own. Remember, this denominator is always the original denominator. You got to have those the same. Okay. Cool. Keep going. This is actually a new topic here. 33. I say I got f of x is equal to 4x cubed minus 8x squared plus 5x, then minus 6. And they say find f of 1. I guess I didn't need a comma over there. Find f of 1. Wait for a second. We're waiting. We're still waiting. Yeah, you plug in a 1. Did you go and look at this one on the homework? I do all this in the calculator. I got a -5. They're wanting you to use synthetic division. They say this is a remainder theorem or something like that. Neato burrito. Super cool, man. Cool beans. But when they're wanting f of x and they have f of x and they're wanting f of 1, you just simply plug in a 1. I mean, there's nothing else to do there. But that's okay. So anyways, you could use this 1 right here and then simply use synthetic division. 1 times 4 is 4, minus the 8 is -4. 1 times -4 is -4, plus the 5 is going to be 1, and 1 times 1 is 1, minus the 6 is -5, and oh my goodness, they're the same number! Either way, you could do either one, but I recommend plugging it in because you don't have to remember anything. 4343. So they have x cubed minus 13x squared plus 47x minus 35 is equal to 0. And they say, given that we have x equals 1 is a 0, find the others. Well, find the solution set. If I say find the others, it's not quite like that. Find the solution set. They want to solve for x. Can you solve for x here? Start factoring. Go on. No. You already know me. You already know that's not going to happen. So how am I going to get all of my zeros from that? I recommend using this 1 right here, literally a 1, and I'm going to use synthetic division with it. 1x cubed, negative 13x squared, 47x, negative 35. Why am I using synthetic division? Well, first off, it's in this section, but I want to show you the reason for synthetic division. Why it's so super cool. 1 times 1 is 1, minus the 13 is negative 12. 1 times negative 12 is negative 12, minus the 47 is, looking at my notes here, 35. Yay. 1 times 35 is 35. 35 minus 35 is a 0. Yay! Yay! We like when we get a remainder of 0. And the reason why is because it's a 0. It tells us, hey, this is a 0. This will be vitally important here in the next section, 3.4. As of right now, I'm just showing you kind of like, the basics. what we get out of this is now our quotient. This is x squared. I got now x squared minus the 12x plus 35. And so let's zoom out. What did I do starting with, like here? Let me scroll and show you what I'm really talking about here. When I did like real division here, you know what I mean? And I said, well, what's the answer? That kind of stuff. I want to know what I actually started with before this synthetic division stuff. What I was really wanting to do out of what I just did here, this is what I did. I said x cubed minus 13x squared plus the 47x minus 35 divided by x minus 1. Come on, what's the factor? X minus 1 equals 0. Opposites. This resulted in x squared minus 12x plus 35 with a remainder of 0. So you don't even have to write that. This is what you just did. You said this and this is the same thing. And remember that you were saying that this guy's equal to 0, so I bet that this guy's equal to 0. I just need to keep solving for x, but now using this one. I'm going to continue to solve for x here. So, what is this guy? How do I solve for x there? Maybe I'm doing too much theoretical. Synthetic division, take the quotient. When you're done with the quotient, you're going to just keep factoring. Yes, factor is the word. I'm going to factor. I think I might maybe do too much theoretical sometimes, sorry. What two numbers multiply to make a 35 and add up to 12? 7 and 5. So I got a negative 7 and a negative 5. And so you can see that I solve for x. X equals 7. X equals 5. And guess what? Those are answers. As well as x equals 1, which they had given me. So before I do any more theoretical, your solution set is very simple here. 1, 7, and 5. Any order will be accepted. You can put it in any order. Awesome. Now we're done with that problem. That was it. But now let me talk one more time because I got to. Notice this original. This x cubed, let me rewrite it, minus 13x squared plus the 47x minus the 35. What if I were to actually say factor it? Well, I could tell you that one of the factors is x minus 1. We just found that. Here's another one, x minus 7. Here's another one, x minus 5. We just found those. But that's what we just did. We factored. Oh, I zoomed in. We factored this. Now, we had a little help. And then from, to get to there, we did synthetic division. It's a little unconventional. But we can factor. We can solve using synthetic division. Again, that's not such a huge point right now. But in the next section, we'll be doing this every single problem. And so I just want you to be comfortable with synthetic division and the fact that we're getting zeros. Okay. Two last problems, and they're kind of like application problems, word problems, something like that. This one is like kind of like a box. And I have h height. I got a 3h width, and then I got an h plus 7 length. And it says 3 is a solution to this problem, and I think that they give you this big old formula. I think it's the volume. And so they have a big multiple choice part using synthetic division, as in they already have done it. What you're doing is picking the correct synthetic division that looks correct. Some key notes. You're looking for this 3. You're looking for that 0. This guy right there sometimes changes. Pick the one that looks like this. And so they said that 3 was a solution. And notice I got equals 0. So yes, it's a 0. Like, we found out a 0. Look, 0. We got a 0. It is a 0. Like a solution set, an x-intercept, whatever you want to call it. Yay. Like, x equals 3. Well, I mean, it's not x. Sorry, I zoomed in again. I'm getting zoom happy here. It's not technically x, is it? It's h. H equals 3. And that's actually the last part of this problem. So just pick this one. Multiple choice, pick that one. And then they got h is equal to, 3h is equal to, and then h plus 7 is equal to. Well, if h is equal to 3, which we just confirmed, you put a 3 right there. Wow, that was nice. 3 times 3 is 9. And guess what? 3 plus 7 is 10. Okay, great. Last problem. That was my slow clap. They have a rectangle here, shaded in, I guess, and they say that the width is equal to x plus 0.7. And then they say that the total area is equal to 0.8x cubed plus 0.66x squared plus 0.77x plus 0.49. And they're saying, what's the length? Well, if I remember, area of a rectangle is equal to length times width. So in order to find the length, I'm going to divide by the width on both sides. So length is equal to area divided by width. That's kind of like a formula. But notice that we're doing division here. I'm going to do synthetic division. Synthetic division with this width and this guy right here. I'm going to write this out one more time. I do not want to write this out because there's way too many decimals. But I'm doing this because I want to show you the exact reason that I'm going to be using synthetic division. I could just tell you, oh, just use synthetic division, blah, blah, blah. But that's not the point here. We're learning why we're doing this stuff. So, this is what they want. This is equal to your length. Go! Figure it out! Well, synthetic division. Now, I know that looks scary, but right here, I want to solve for x. X equals what? What do you get there? Don't overthink it. Negative 0.7. You got a positive? You change the sign. Now it's a negative. I'm going to do synthetic division with a decimal, and I'm going to do all of the coefficients, 0.8, 0.66, 0.77, and 0.49. Now, before I get started, I want to say I am the worst person to be doing decimal math. Decimals are hard because I'm used to whole numbers, and heck, I'm even pretty good with fractions, but not decimals. So when I say, 7 times 8 is 56, isn't that what it is? 7 times 8 is 56? Yes. But like, is it 5.6? Or is it 0.56? Or is it 0.056? Blah, blah, blah. Use your calculator. Use your calculator. Multiply these guys, and it actually ends up being a negative 0.56. And then I add these together, right? This one's a little easier. I got a 0.1. Multiply, add, multiply, add. 0.7 times 0.1 actually makes a negative 0.07. When you add these up, you get a 0.7. And then 7 times 7 is 49, but you can kind of see what's going on here. Bloop. You should get a 0 at the end. You should. This is the answer that they're looking for. Again, this was x cubed. Now this is x squared. You always reduce it down by 1. 0.8x squared plus the 0.1x plus 0.7. This is your length. Oh, man, we did it. All right, we're done. That's it. Thank you very much. Have a great day.